Hello, CIS40A. In this video, I'm going to go over Unit 12 notes, which is Chapter 12, 13, and 17. In these chapters, we're going to talk about WAN technologies and network management and troubleshooting. So in Chapter 12, it begins with talking about WAN technologies, and this is when we look at service provider technology and how we would connect our local area network to the the service provider as a subscriber. So there are two types of networks. One is going to be packet switching and the other is circuit switching. And packet switching is what we know as today's network, in which data packets are sent through the routers, where it doesn't have to be specific route. It can take different path in order to get there. So it could be open shortest path first. The first available router is going to be able to send the packets through to the destination system. So packet switching is the process of breaking the transmission data down to multiple packets, and it's able to route as fast as possible. And when it's received, it's going to reassemble the packets and verify and present the data to the destination system. So in packet switching, the datagram is shown, the data is passed through the router, and the frames is being assembled before it's passed to the next level, which is the network layer on the OSI. Packets would then be forwarded from router to router, could be the fastest, the shortest. When the router is busy, then it would use a different router to be able to get there. So the analogy for this is like if you are taking different paths to school, one way would be able to cross different streets in order to get to the destination, and other ways would be using the freeway. So if the freeway would be occupied, there's a lot of traffic, then we would be able to take different service street in order to get to the destination. So packet switch network does not depend on the packets that's being delivered in order. They are normally broken down to separate packets, and then when they get to the destination system, it would use the protocols and the sequence number to reassemble the packets. So in the first question of your assignment, it asks you the main difference between packet switching and circuit switching networks. The packet switching is a process of breaking the transmission down to multiple packets to take different routes to the destination network. And the packets are received out of order. It would then use sequence number and protocols in order to put the packets back together and present that to the destination system. In circuit switching, the circuit is then open, and this is where you would get the dial tone on your telephone, where that circuit is open. And when the call is made, both of the phone, the target destination phone and the source, the caller would then have to have the circuit that's open. So when you dial the number, it would then transmit that information and be able to send data across. And so in the legacy network, we normally would see circuit switching using the telephone networks. So whether we send data or voice, it would then be sent via the media or the telephone lines. And the packets, when you send the data, is not broken into separate multiple sub packets or being rerouted. It would just be a straight transmission from one point to another point. And so it would be less efficient than what we would see with packet switching, in that bandwidth would then be consumed even when the data is not transmitted as the circuit remains open. It would have a permanent path, and so therefore we don't have a redirection. And so if the circuit is busy, or it's being used for other reasons, then the voice data or the data cannot be transmitted. So it needs to have the circuit to be able to establish each of the call. So that's the main difference between circuit switching and packet switching. And after this section, it goes into X25 and frame relay. So X25 is a packet switch network. It uses packet assembler and disassembler called PAD. This is used to connect system, and it would use serial port such as RS232. And this is what you see with the DB pins that will be connecting, and serial ports tend to be a lot slower than what you see in the later ports. And so X25 runs in the OSI layer 1, 2, and 3. So it would be the physical, the data link, and the network. And it would transfer up to 2 megabit per second using analog line, which is your telephone line. And compare that to the frame relay, which is a digital version of X25. Frame relay is faster. It operates in the physical and data link layer, layer 1 and 2 of the OSI model. And it is used for ATM, broadcast, ISDN, or cell relay. So the later technology rely on the frame relay in order to transmit data, and the transmission speed for this is not constant. It would use a way to manage error, which is known as the Inter-Network Packet Exchange or Secret Packet Exchange, IPX and SPX, or it would then rely on TCP/IP. So transition from the legacy network, which uses IPX and SPX, to the more current or closer to modern network, we would see the TCP/IP being used. So all nodes are used to route the frames of the packet switching network, and it would rely on the algorithm for efficiency to be able to send the frame in variable length packets. Now, when the network bandwidth is not congested, then it would be able to transmit normally. But if it is congested, frame relay would drop the frames and that it could not handle, such as corrupted frames or undeliverable frames. So it would become less in order to use the existing bandwidth to be able to transmit the frames. Now, the bandwidth is based on the subscription tier. So when a company subscribe to a certain tier, it uses a CIR, or what's called committed information rate, to be able to manage the frames, whether to determine whether the frames are dropped or not in the case of congestion. So the nodes would then keep the statistic of the bandwidth and how it's used based on the tier of subscription. So therefore the algorithm would then be variant to what we would see the type of subscription that's used. Now, next is the fiber optic technologies, and this, unlike your lab, it's going to go over the legacy fiber optic going and transitioning to the current fiber optic. So what we've seen in the past is what we have what's called the SONET network, or the synchronous optical networking, and synchronous digital hierarchy. These were the standardized protocols that's used to transfer multiple digital data bit streams synchronously over the optical fiber using laser or LEDs. So the low transmission rate data is transferred by using electrical interface. And so this was developed to replace the PDH, which is used to transmit large amount of data over telephone lines. And fiber optic would then be used to synchronize the signal. So in SONET and CDH, essentially would be designed to transport circuit mode communicators such as DS1, DS3, and various type of sources. It would be difficult to really synchronize the sources in various circuits that are different. So if each of the circuits are meant to operate slightly different rate in different phases, then it would be allow simultaneous transport in different circuits by origin, by frame protocol. And so it would classify under the frame protocol in order to transmit or transport based on neutrality and orientation features. So if we apply this to ATM, where frames are considered as cells, it would then be able to map the structures and concatenate the payload for the containers to be able to transport ATM connections. So hence, we would have complex structure in order to transport the connections and remove and replace large concatenate frame where it would drop that to be able to reduce the congestion of the packets or the cells. So now Sonnet would work with ATM cells, IP packets, and Ethernet frames. So it was able to adapt to what we would see transitioning to our current network. Now, both CDH and Sonnet are widely used today. Sonnet is used in the United States and Canada, whereas CDH would then be implemented in Asia, Europe, and other parts of the world. The standards for Sonnets are listed with known as the optical carrier or OC standards, and each of the OCs are made of a different type of bandwidth. So what you would see here is that it would be able to subdivide it into different layers to be able to provide different type of bandwidth. So OC1, it doesn't have any CDH level, and that will be transmitting at 51.84 megabit per second. So make sure that we know the OCs for Network Plus. Whereas OC3 is 3 of the OC1s, in that if you take the bandwidth for the OC1 and you multiply that by 3, you would be able to obtain 155.52 megabit per second. So that will be Sonnet Electrical Level 3 or STS3 compared to STS1, and so on. So they are multipliers of the OC1s. So the OC9 is going to be transmitting at 466.56. So if we take 9 of the OC1, that will be equivalent to the OC9. So here it gives you a little bit of explanation on the standard on how they could be varied based on different OC channels. The important thing that we want to focus on is that they are consisted of different DS1 and DS3 channels. So in the SCM1 or the synchronous transport module level 1, in which it would be 155.52 megabit per second, that will be the basic unit to frame for the SDH, whereas the basic unit in the Sonnet, that will be STS3C, that will be synchronous transport signal 3 concatenate. So when you're looking at Sonnet network compared to other type of optical network, you would see that the basic units are considered to be different. Therefore, it would use different OC level, such as OC3 for STS3C, and it is designated for the standard with no difference in comparison between ST3 and ST1. Now, the basic unit for the transmission using SCS1, which is a synchronous transport signal 1, that will be operating at 54.84 megabit per second, as we mentioned earlier. The speed would then be dictated by the bandwidth requirement based on whether it's for voice signal or data signal. So then it depends on the type of manufacturer and the type of network. Now, when you're looking at LTE, which is what you see with T-Mobile, that would then send the SCS signal on both ends of the Sonnet media. And so the Sonnet link might not be on a single connection, but it would then be from one point to another in the segment of composed Sonnet media. So in fiber optic, it would then use wavelength division multiplexing, which is known as WDM technology, where multiplexes are used with several OC signals onto a single optic fiber using different wavelengths. Now, there are 3 different wavelength patterns. There is normal wavelength, which is classified as normal WDM, coarse wavelength or CWDM, and dense wavelength DWDM. In the normal wavelength, you would have 2 normal wavelengths of 1310 and 1550 on one fiber, whereas coarse wavelength, you would have 16 channels across multiple transmission windows with silica fiber that would enable to reach 120 kilometers. So coarse wavelength goes a lot further than the normal wavelength. And it's able to carry multiple channels, like what is described there. And then you also have the passive coarse wavelength, division wavelength. Then you would have the implementation of coarse wavelength with no electrical power. That is considered the passive. In the dense wavelength division multiplexing, the DWDM, this is referred as the optical signal multiplex within 1550 nanometer band, and it would be doped with the fiber amplifier, your EDFAs. That's effective wavelength between approximation of 1525 and 1565 nanometer in the C band, or 1570 to 1610 in the L band. Now, compare this to the coarse wavelength. Your dense wavelength is then using 40 channels at 100 gigahertz spacing, or 80 channels with 50 gigahertz spacing. And that would use denser channel spacing, so that way we would be able to transmit at a higher bandwidth. And so the dense would then be used in ATM, SONET, or SDH, and Ethernet networks. As the picture is shown here is how you would be able to implement the dense. So coming back to the assignment, in the next question, it asks you what technology is used in X25 switching networks? What is the transfer rate of X25? X25 uses packet assembler. This assembler calls PAD and is used to connect the system. PAD is connected to the serial port of the device, such as the RS-232 compliant. Question 3, what layers in the OSI model does frame relay use? What is its transfer rate? So frame relay uses layer 1 and 2 of the OSI model, which is physical and data link. Its transfer rate is up to 50 megabit per second with the features such as quality of service. So without quality of service, you actually have lower than 50 megabit per second using frame relay. For question 4, what protocols are used to transfer multiple digital bit streams synchronously over optical fiber using laser and LEDs? That will be your synchronous optical networking, which is known as SONET, or synchronous digital hierarchy, which is your SDH. That's the prevalent backbone of what you've seen in a lot of the networks today. Question 5, what is the transfer rate of the OC1? That will be 51.48 megabit per second for the OC1. So if you have the OC3, that's triple that. So you would take that, multiply it by 3, which gives you approximately 155 megabit per second. For question 6, what are the 3 types of wavelength division multiplexing? We have the normal wavelength, which is your NWDM. Then the second will be your coarse wavelength, CWDM, and the dense wavelength, which is DWDM. And the difference in these are the type of channels the number of channels that are being used. So the coarse uses 16 channels and the dense uses 40 channels compared to the normal, which uses a single channel. The number 7, what type of rings are used in fiber distributed data interface, your FDDI? It uses 2 types of rings. It uses the primary and secondary rings. The secondary ring is used as a backup, and these 2 rings are used to pass token in the opposite direction. So in the case the primary is down, the secondary would then be continued to be used to pass the token. So that way it would have communication in the network. So now coming back to the notes, we would then visit FDDI, or Fiber Distributed Data Interface. This is a standard for data transmission in your local area network, in your LAN, compared to what we talked about with SONET and SDH. That will be the connection to the WAN. So the physical medium would then be used copper cable, where we would be able to adapt copper cable, which would be Ethernet or Coaxial. So in the case where if we're using copper distributed data interface like the coaxial, we would use CDDI. Whereas twisted pair physical medium dependent would then be used with Ethernet type of cable that will be your TP-PMD. And so when we adapt this to the distributed data interface, that would be TP-DDI. So the fiber distributed data interface would then be made obsolete in the local area network by the fast Ethernet because your Giga Ethernet is actually faster than the FDDI. And so FDDI uses two rings, primary and secondary ring. Secondary ring is used when the primary fails. Token is passed on each ring in the opposite direction. It can be used in local area network or campus area network or CAN. And so when we connect building to building, it was used to connect building to building or floors to floors in the tall rise. And so both rings would then be connected on the DAC, or what we know as a two single attachment concentrator, which is SAC. And so if any ring should break, the SAC or the SAC is shut down, the network will still be operate as it would have a fault tolerant type of architecture. And so a picture for this would be shown on page 6 of your notes. And to go further into the ATM network, ATM was a way that we would switch using telecommunication network or the phone line. It is used in the asynchronous time division multiplexing for encoding the data in small fixed size cells. And so each of the cell would then be used to in place of what we know as a packets. And so the ATM was adapted for voice or data converting the packets before it converts the packets, it would then be used. In a case where we would have a large packet data or burst data, it would be able to pass through the same medium where it would then set up the cells and be able to use the same path. So the cell consists of 5 bytes header and 48 bytes payload with a total of 53 bytes. So Network Plus will ask you what is the cell size for the ATM, which is 53 bytes. 5 bytes header and 48 bytes payload. And the traffic would be constant or variable. It would then have fixed routes from 2 points where it begins and where it sends to using TCP/IP suite. Therefore, it would then be able to adapt to the TCP/IP protocol. It is less adaptable in the case where we would have network traffic search, where we would have large bursts of data. And so your data packets would then be converted to what's known as cells, as we mentioned earlier. The digital transmission would be light pulses, either on or off. And so ATM was used to enhance ISDN, especially if the ISDN is using low transmission for voice data and packets, or it can be adapted into the broadband cable television network or using multiple channels with different frequencies on each channel. It would allow speed up to 622 plus megabit per second, sending voice and video in great distances. There are 4 different bit rate of choice in the ATM network. It would then be available bit rate, constant bit rate, or unspecified bit rate. So the available bit rate is to guarantee the minimum capacity of data can be burst into higher capacity of the network traffic. Constant bit rate would be a fixed bit rate size that we stream across the network using lease line. And unspecified bit rate doesn't guarantee any kind of throughput that is used for file transfer and applications, and it would tolerate delays. So there are 3 types of bit rate, and depending on the subscription with the ATM network from the service provider, you can select the type of bit rate that will be accommodating for your company back then. With internet technologies, we would have different type of connections with the service provider. A company can subscribe to a lease line which is known as the TX or E carrier. TX is used in US, Japan, and Australia. It consists of 24 channels that are made up of 64 kilobit per second each. So the total for this would be 1.54 megabit per second. So on a T1, on a tier 1, that will be 1.544 megabit per second. A T1C, that will be triple of the T1, and the T2 will be double of the T1C. So in each of this channel would be 64 kilobit per second, which is known as your DS0 or digital signal level 0. 24 of the DS0 is equivalent to a DS1, which is what known as a tier 1. And company would be able to lease partial of the tier 1, which is known as a fractional T1, where they would be able to operate at a fractional speed, so a lot less than 1.544 megabit per second, and they would apply monthly fees for the lease line. E-carrier is then being used in Europe, Mexico, and South America. It composed of 30 data channels in 2 signal channels of 64 kilobit per second each, totaling 2.048 megabit per second. So as you can see, E-carrier is slightly higher than your TX carrier that was used in North America and Australia, as it would use higher data channels coupling with the 2 signal channel for the E-carrier. So the E2 carrier would consist of 16 T1 carrier channels, which is equivalent to 34.368 megabit per second. Now, when you compare from E1 to E2, E2 is quadruple the E1 and E3 is quadruple of the E2. So every time we would multiply that by 4 for the E carrier, and when you compare the E1 to the T1, the E1 is almost double the T1, and E2 would then be 16 times of the T1. For the termination of CSU and DSU channel service unit and data service unit, this was a device that would be used to connect to companies like telephone company to be able to use T1 or T3 links. And the CSU DSU is simply a way that we can connect to the service provider, and we would use what's called the external CSU and DSU, which uses the serial port of the router to be able to connect to the T1 link. As the picture is shown here, you would have a CSU DSU connecting to the T1 line, which is then connected to the service provider network, and then the router would then be connecting to the CSU DSU using a serial port. And on the router, the serial port would look like the image is shown on page 8. Now, there are 2 things that you need to know for the Network Plus and for the final exam. One is going to be the demarcation point, which is a point where the service provider equipment connects to the building, which is used to determine the responsibility and the maintenance and the repair of the service provider. And Smart Jack is a demarcation point that serves as CSU DSU to convert the signal and generate weakened signal, perform diagnostic troubleshooting. So Smart Jack is different than the demarcation in that it does do diagnostic and it does monitor the signal, compared to just simply the demarcation point is a way that we would connect to the service provider. So from your home, from your house box to the green box on the street or on the sidewalk, what you would see is those green boxes are the demarcation point for the service provider. So they are in charge of that. So they would be able to service the lines that would go to that box. Your DSL and ADSL digital subscriber line is DSL. This is used for high-speed internet service that would connect over the phone lines. there are two types of DSL. There's the asymmetric DSL subscriber, ADSL, or SDSL, which is symmetric digital subscriber. The difference between these two is that the asymmetric digital subscriber uses different upload speed compared to download speed. And the download speed can be up to 9 megabit per second, whereas the upload speed would be up to 1 megabit per second. So the transfer rate would differ between download and upload for ADSL, and the subscriber would need to be connected within 5 kilometers of the central office of the phone provider. The ADSL uses splitter, which is used for filtering frequency. It would then connect to the phone jack in the wall, and then the splitter would then have a line to connect to your modem. And that would give us the in and out for our phone and our data. Symmetric DSL, SDSL would have the same download speed and upload speed. And so each type of DSL, you would still have to use the DSL modem. Broadband cable is another way that we would connect to the high-speed internet service using coaxial cable and cable modem. The cable modem would be connected to a cable splitter that would then be connected to your cable TV outlet. And each of the channel would have a different frequency range, or has a frequency range of 6 megahertz. And in that, data is separated on each of the channel. The download speed can reach up to 10 megabit per second. So as you can see, it's slightly higher than DSL. And the downside about cable is that you do share bandwidth with the neighbors that uses the same provider. So as the line would run down to your neighborhood street and then subdivided into each home, so that way you do share the bandwidth with the neighbors. And so the plus side of this is that you don't need to be close to the central office of the service provider, as it will be able to go larger distance with the cable or coaxial cable. Satellite and cellular network. Satellite internet can be used to be able to connect to the internet. It would use satellite dish, and in addition to the dish, you would need to have two modems using coaxial cable to connect, one for upload and one for download. And the transfer rate for satellite can be up to 500 kilobit per second, so it is a lot less than what you see with cable internet or DSL. And it also depends on weather and the satellite itself, how it would be able to have line to sight signal. In the cellular network, we would have GSM and CDMA. GSM stands for Global System for Mobile Communications, which is a cellular standard for 2G. This is for 2G was then digital cellular network compared to 1G, which is analog networks. So cell phone that uses SIM, subscriber identity module, would use GSM cells to be able to connect. Now, different from that, code division multiple access CDMA is a multi-access method using radio communication, using CDMA 2000, which is implemented for the 3G mobile technology, using voice and data with the mobile devices. So 2G stands for second generation, and that was an improvement from the 1G, which was analog. And so on the 2G, your phone conversations are encrypted and it supports text messaging. GSM is an example of 2G. 3G is third generation. It provides a bandwidth higher than 2G. It supports data, voice, and video. CDMA is an example of 3G networks. LTE and 4G. LTE stands for long-term evolution, and 4G is fourth generation. This is now able to implement wireless network, giving broadband services over mobile devices, so you can tether on your phone for other device to use your phone as a internet connection point. And so you can have speed up to 300 megabit per second. And then we would have the later generation, which is the 5G, also as HSPA, Evolved High-Speed Packet Access. This is known for broadband solution-based wireless technology that can have speed of 22 megabit per second for upload and download as 84 megabit per second. Edge is for enhanced data rates of GSM evolution. Edge is an upgrade from the GSM. This is a cellular technology that is backward compatible with GSM, which transfer rate can be 3 times of the GSM transfer rate. Then we have WiMAX, which is Worldwide Interoperability Microwave Access. This is an internet access using microwave without wires, and it would have transfer rate between 40 megabit per second on the old type of architecture, and on the newer type that will be 1 gigabit per second. Then we have the Metro Ethernet or the MAN Ethernet. This is now implemented in a lot of like the metropolitan area, like cities. Internet access that would be gained by connecting multiple offices together. So that way the public can also have internet access. PPPoE, this is point-to-point over Ethernet, which uses DSL line to encapsulate PPP frames. And that will be sent from the client to the service provider network. So it needs to be encapsulated using PPP. So that way it will be transmitted over Ethernet. DMVPN, which is Dynamic Multiple Point Virtual Private Network. This is a hub-spoke topology where the endpoints would connect securely to other endpoints in the network via the virtual network using either web-based or using protocol connection to the firewall-based type of network. Then you have SIP trunk, which is for voice IP technology to stream media services using service provider unified communication solutions for real time. So in the next few questions, for number 8, what is the size of the data packets being passed on ATM? Data packets would then be referred to as cells, which has fixed size of 53 bytes. 9. What are the two types of lease lines and how are they used? We have TX and E carriers. TX is used in United States, Japan, and Australia. And E carrier is used in Europe, Mexico, and South America. The carriers would then be useful if you have a full tier 1, or you can use fractional carrier that can be leased for a fraction of the cost and speed to transmit voice data and images. For number 10, how is channel service unit data service unit used in the organization, CSU and DSU? This device is used to handle signal over T1 or T3 links, sending data between service provider and the router. It's used to protect against electrical interference for either side of the link. Question 11. What is the primary difference between the demarcation and smart jack? Demarcation point is where the service provider equipment connects to the building, which is used to determine the responsibility in the maintenance and repair. The smart jack is also a demarcation point that serves as a CSU-DSU to convert signal and regenerate weakened signal, perform diagnostic and troubleshooting. So smart jack is above the demarcation in that it does the diagnostic for troubleshooting and it regenerates the signal. For 12, what is the primary difference between asymmetric digital subscriber ADSL and symmetric digital subscriber SDSL? ADSL has different download speed compared to upload speed, whereas SDSL download and upload speeds are the same. 13. What type of devices are used for satellite internet connection? And for the satellite service, you would need to connect 2 modems using coaxial cable, one for upload and one for download. 14, what type of mobile networks are example of GSM and CDMA? 2G is an example of GSM and 3G is an example of CDMA. And so now we are going to go over maintenance support in the network and troubleshooting. So chapter 13 and 17. So in chapter 13, it talks about network upgrades and downgrades. And downgrades happen when we need to retire systems or segment of the network. And so before you do anything, you need to review documentation and look at the configuration of your existing system before you do upgrade or downgrade. Especially when we're looking at upgrade of software and hardware, you would never ever perform an upgrade for the first time on production system because likely that you would run into error and that will cause disruption in your business. So we would perform all the configuration backup first before we perform upgrade. We would follow the safety practices to perform system upgrades and also looking at the different type of hardware devices. We would also use material safety data sheets or MSDS in order to determine if when we dispose our components and parts and system, whether they contain hazardous chemical that will be found. And so we would follow the safety measure in order to properly e-cycle or dispose these type of systems. We would protect ourselves against electrostatic discharge or EDS using anti-static wrist strap and touching metal surface. And when you lift heavy equipment, you would lift with your legs and get assistance from others. To make sure that when we install equipment on racks and in the closet, we want to make sure that we have adequate airflow and cooling. So we would place all our equipment and servers in the properly cool area. We would use proper tools to remove jewelry before we would install hardware devices. And additionally, we want to have emergency procedures, building layout, fire escape plan, fail open, fail close plan, fire suppression, emergency alert system, HVAC, and all the proper updates for software OS, drivers, and hardware and firmware. In dealing with fixes and patches, we would prioritize security hotfix that is critical for securing your system with updates that must be applied immediately. We need to patch and fix OS and software to reduce security risk. We can use Service Pack, which consists of security hotfix and patches that can be installed together instead of individually. Any kind of feature and changes in the updates, we want to review the features and changes before we would perform upgrade and updates. Any kind of minor and major updates would consist of new features for the major updates, and the minor updates would consist of improvement to existing features. So we got to look at those changes. We want to patch vulnerability, so we would research the existing vulnerability and how to deploy the fix for that. So we must first test the fix before we deploy the fix. Microsoft has a server role called WSUS or WSUS. This is a Windows Server Update Services. This is a role that's used for update services and testing and deployment of updates. We also want to use anti-malware software tools to detect and protect system from malware infection using signature and heuristic definitions from the service provider. We want to schedule scan, update definition, doing real-time protection, scan email, websites, protect browser from being hijacked, and automatically update malware definitions. Additionally, for the backup of network, we want to schedule regular backup to network drives, cloud space, or tape drives. Tape drives is old, but it's still being used. So depending on the capacity of the tapes, in the table here, it shows you the storage capacity for your digital tape drives. 2 gigabyte is the DDS. DDS1 is 2 to 4 gigabytes. DDS2 is 4 to 8, and so on. And you need to perform tape rotation based on schedule, which could be daily, weekly, or monthly. And all the tapes need to be sent to offsite storage. In the case of natural disaster, you would still have the backup tape. All backup starts with the full backup. And after that, we can choose between incremental backup and differential backup. When you do a full backup, it would change your data attribute bits to archive. And so this would set the archive bit so that way we can manage our incremental or differential backup. Now, to archive, simply we would store data to a different location, such as offsite, to prevent data loss. So after a full backup, we can choose an incremental backup, which back up all the changes that had been made since the last full or the incremental backup. So how does it know? It would look at the archive bit that was set. So when you complete a full backup, it sets the archive bit. And in addition, if you do an incremental backup, which back up the changes since the last full, it would also set the archive bit. Now, when it is used, when we would recover, it would reset the archive bit and report that the files would then be recovered. So when you restore, you would restore with the full backup and then the incremental backup. Incremental backup does take a lot less time to do a backup compared to differential backup. But when you restore, it would take more time than the differential backup. In differential backup, it also back up the changes that you've been made since full backup or its last differential backup by looking at the archive bit set. But it does not clear the archive bit after the backup is done, so it simply creates a copy of the actual changes. So backup will give us fault tolerance in the case where if our data is corrupted or damaged, we would be able to retrieve the data. Now, the backup needs to be either stored offsite via cloud on a server that is somewhere else, or using RAID drives, which would then be sent to an offsite location. We can also implement RAID drives, failover system, backup power supply, your uninterrupted power supply, your UPS. Along with having fault tolerance, you need to have network documentation and configuration management. We would document network diagrams, wiring diagrams, rack diagrams. We would also identify port locations and connectivity purposes. We also need to document intermediate distribution frame, your IDF. That will be your wiring closet to floor or for each floor and building. Your main distribution frame, your MDF, which is the panel that connects to the main line from the service provider. You also need to include physical network diagrams to your router, switch, WAN links, and cabling and servers. A logical diagram or logical diagrams that will contain domain controllers, IP addresses, servers, and VLANs. We would have a list of inventory and labels to our assets, location, and responsible individual to manage those assets. We would have a list of IP address utilization, IP address range, assigned IP, static IP, and scope. We would have vendor documentation for configurations and technical support details. We would have documentation that consists of baselines, which would be statistics on normal activities that would be then used for troubleshooting and performance evaluations. Our documentation should also include policies, procedures, and standards. Policies such as password, account lockout, user rights, audit, firewall, and software policies. These are rules that are written and configured to restrict or control network resources. We would have procedures, which are steps to perform configurations and maintenance on troubleshooting devices and respond to incidents in case of emergency. Then we would have documentation on standards, what would be defined as requirements and specifications needed for compliance reasons. In change management, these are the steps to implement changes to the system. We would follow the step as followed with 7 steps or 8 steps. Determine the change that's needed, test the change in the environment, prepare tests for backup plan, create a backup plan before implementation, schedule time for change, implement change, verify the state of change, and document the process and results. And along with the documentation, we want to have change management procedures. We need to have the reason for our change request document, approval process for the change request, clear authorization for downtime and maintenance window, and also notification of change and reporting procedures. With change management, we also need to include configuration management. How do we configure when we have new objects such as users, employees, and systems? How will we be able to add devices to the network with using management software tools? We would also verify functionality of the device and security compliance. And we would use network access control NAC to control devices that access network resources based on health requirements that are being met by the client systems. Such as when you connect the laptop to the network, right? It needs to have anti-malware and anti-malware scan and updates along with certain type of safety precautions, firewall, and other things. So in the next few questions, we can say that for 15, explain why we should not upgrade production system first, because failure to upgrade can cause disruption in operations. We should test upgrade on standalone system and gradually deploy it on the network. And with that, we need to do change management and configuration management. 16. What is the difference between security hotfixes and service pack? Service packs consist of security hotfixes and other patches in which they can be installed altogether when the service packs are installed. 17. The 7 steps in troubleshooting the network. When you come across a problem on the network, you first need to identify the problem. Second, you would then look at the probable cause or establish a theory of the probable cause. Then we want to test the theory to determine the cause. Then we want to establish the plan of action to resolve the problem and identify potential effects for that resolution. After that, we would implement solution, or if we cannot solve it there, we need to escalate further. And we would verify full system functionality if it's working and implement preventative measures. Lastly, we will document findings and actions and outcomes. So in chapter 17, it talks about troubleshooting the network, and those are the steps. So we have to ask ourselves, does this problem exist across the network or just on that individual system? What is the scope of the problem? Is it LAN or WAN? When we test a theory, we need to look at, is it replicable or is it consistent? Where is the source of the problem? Did the device ever work? When was it last known working? What has changed since it was last working? So in identifying the problem, we need to gather the information from the problem. We can ask the user, We can use utility and commands such as ipconfig, ping to be able to determine the connectivity problem. We would look at the symptoms and the effects of the problem. We would determine if there were changes or recent changes to the device. We would try to duplicate the problem to really see its effect and its cause. And we would approach multiple problems individually. When we establish the theory for probable cause, which is the second step, we would list all the probable causes and prioritize them. What would be the highest priority essential to that type of problem? We would question the obvious and use the top to bottom or bottom to top OSI model troubleshooting procedures. We would divide and conquer by breaking the problem down to smaller components and troubleshooting them individually. Third step is to test the theory to determine the cause. Use a known good working device to test the cause of the problem and see if it's a way that we would correct it. If the theory is not confirmed, we would reestablish the new theory or escalate the problem. Then next, once we have identified the cause and test the theory for the cause, we would establish a plan to solve the problem. But first, we need to identify the effects of change, because sometimes when we solve a problem, we can create other problems. So we would develop a step-by-step action plan to solve the problem and try to mitigate other problems when solving it. Implement solution and escalate if necessary is where we would apply our plan and be able to give the solution for our network. If the case that we cannot solve it, we would escalate to the next layer. And sometimes that could be, above and beyond the local area network. Verify the system functionality is where we would check if our solution is working. Avoid introducing new problem for the fix. Develop preventative measure to avoid having the same problem in the future. We would then teach the user if it's a user error, or we would then apply proper configuration to prevent that happening to other systems. Lastly, document findings and actions and outcomes. We would record initial problem, symptoms, and corrective actions along with the final outcome. So that way we would be able to refer to it in the case where we have the same problem occur. So there are common type of network errors and indicators. There are two categories: system error or the user error. And system error would then be like hardware failure, or user error would be how the user interact with the system, or could be a misconfiguration of the device. So we need to check two indicators. One is the physical and second is the logical. On the physical side, we can check link lights, power lights, error display, or logs. On the logical side, we would then look at things like protocols, sessions, how the sessions are terminated, managed, and created, how RTP would then be used, especially for voice over IP. We can also look at quality of service features and how the configuration of QoS is used to prioritize traffic shaping, caching, and also for availability. So in high availability, we can use high availability clusters, which are servers and primary nodes that are used for failover purposes. We can implement load balancing, distribute across different servers to improve traffic transmission, and also fault tolerance to reduce failure in the case where if you have a single system that's failing, and also reduce the risk by using Common Address Redundancy Protocol CARP, where multiple systems can be configured as a group in a virtualized environment as a backup. In the physical area, we can check for cabling, and cable can have various problems such as attenuation, latency, jitter, bad connectors, bad ports, bad transceiver, incorrect terminations, and so on. So attenuation is degradation of signal Latency is just a delay due to high traffic utilization. Jitter is just random spike in the router and switch to deliver information. So we can use QoS to control that on the router side. And in the case of damaged cable, incorrect terminations, we can replace the cable, we can replace transceiver, we can replace and use devices to look at our decibel and signal loss, such as multimeter and cable tester to be able to test to see if signals are transmitting across the wires. So here it gives you various type of issues that could be happening on the physical side. On the logical side, we might have bottleneck, VLAN mismatch, gateway or IP address error, duplex speed mismatch, wrong DNS. So all of that really comes back to the configuration of the administration of the network. And so we sometimes would then have block on the firewall to prevent discovery of your neighbor nodes, or when you have packets being dropped. So some of this would then be resolved by tracing back the issues from the configuration side and looking at using the utility and the commands in your command line in order to resolve some of the problem, such as NS lookup for wrong DNS, or looking at IP config or IF config to look at your IP address. Then we might have security issues where we have infection of malware, misconfiguration of firewall or ACLs or application, attacks, open or close ports, creates vulnerability, ICMP, malicious user authentication, backdoor access, and so on. So I added some of the recommendations on how to resolve some of these problems. And we might also run across WAN issues where we would lose connectivity. And a lot of this going back to the service provider side, where if they have no connection, we will have no connection. So we might consider having some kind of secondary, not using that service provider for our critical transmission, so like satellite or alternate way to connect. Interface errors, where it would use different type of interface and device. And then in the case where we would use routers to send packets for redirection, split horizon can prevent the routers from doing that. And we might have the DNS issue, so we want to be able to look at our DNS configurations and to resolve the DNS correctly. Or we might have satellite issues, policy and equipment issues. So some of this can also lie in the WAN area, where we have to be in touch with the service provider in order to resolve some of the problem. Network troubleshooting tools. These are some of the recommended tools for you to troubleshoot the network. In the physical side, cabling tools, crimper, stripper, compression tool, tester, wire cutter, and punch down tools are critical. When you troubleshoot telephone lines, you need to have toner and toner probes. And when you need to test cable signal, you can use time domain reflectometer, TDR or OTDR. Oscilloscope can be used to look at shorts and attenuation in the signal. Multimeter can be tested to be used to check signal NDB. Spectrum analyzer can also be used to measure signal strength. And then protocol analyzer and packet sniffer, we can take a look at the logical side with that. Looking at the configurations of our system communication and so on, so we can analyze how packets are passed. Speed tester and throughput tester, we can use different type of website to look at our transfer speed. And then lastly, we can use SNP, which is System Network Integrated Polling Software, which is used to monitor temperature and network activity on our servers. And there are other monitoring tools that we can use, but these are the basics that's recommended with the chapters. So in 18, it asks you to identify the tools that's needed to troubleshoot the physical issues, and we just went over those. you can refer to the last page of our notes for the type of tools that's needed for the physical networks. And in this lecture, I covered chapter 12, 13, and 17, in that we talked about WAN technologies, internet technologies, our network management procedures, steps, policies, along with network troubleshooting techniques and tools. And thank you for watching the video.